And the only reason we call it special cases is because we might be multiplying the same thing twice to get something like this, or we might be multiplying like something to get the difference of two perfect squares like this, okay? So the process is the same. However, your answer is going to be something like this, because our a is our variable. It's going to be a plus or minus something squared. That's why it's a special case, okay? Process is the same if you're getting confused right now, okay? So let's just split this into factors. Split this into factors, 1 and 25. However, because these are special cases, you can know right away that it's not going to be 1 and 25. It's going to have to be the same number. So what times itself equals 25? Well, that's 5 and 5, isn't it? So 5 times 5 is 25. And then 5 plus 5 is 10. So boom, there we go. That's the answer. A plus 5 times A plus 5. So a plus 5 times a plus 5 can be written a plus 5 quantity squared. Same thing. That's your answer. And if you multiply this thing out, you will indeed get what you started with right there. Okay, so that was a special case, first type of special case. Perfect square trinomial. Here's another perfect square trinomial. Let's see if you can do this one on your own. Okay, this process is the same, P and P. For the factors will be the same. So whatever two numbers multiply, not two numbers, but whatever number multiplies by itself to get 4, that's going to be the number you want. And so you know that that is 2. So 2 times 2. Now what we have right here is a negative 4 there. So that means that we're going to have to use -2 and -2. Remember, for a positive number here, both numbers can be negative or they can be positive. Those are two possibilities there. Okay, so P minus 2 times P minus 2. And that is our answer. We multiplied the same thing, this P minus 2 by itself to get that. So we call this a perfect square trinomial. And another way to write this is right like that. P minus 2 quantity squared. Check it. Make sure it works. Make sure that this is what you get when you multiply this out. Okay. Last one. R squared minus 9. Okay, this is called the difference of two perfect squares. Why? Because you have a perfect square here and a perfect square here. What is a perfect square? It's something we got by multiplying a number by itself. Now I'm going to show you the old-fashioned way first, and then I'm going to show you the cool way. Well, I shouldn't say cool way. It's just another way to do it, but it's a little faster if you get used to it. Anyway, I'm going to do this in green just because I'm tired of pink right now. So r squared, you would write it out like this. So you're rewriting it first. Rewriting it first. Plus 0r minus 9. Is that not true? 0r. 0r is basically equal to 0. So you can write 0 anywhere. You can add 0 to anything and it will still be the same thing. But this is how we're going to write this to help us understand how to solve it. So we've got a -9 here. And with the difference of two squares, factoring the difference of two squares, this number here, we're going to have to find what was multiplied by itself to get it. And if you know your multiplication tables, it's 3, right? So 3 multiplied by 3 equals 9. But one of the numbers had to be negative because it's -9. Okay, so that means, oh yeah, and we split this into factors as well. Can't forget that. Our answer is going to be r plus 3 times r minus 3. Okay, so that is how you factor the difference of two perfect squares. Now, you just did it the way you did it on all these other problems, but here is a trick. Whenever you have something like that looks like this, that is two perfect squares, a squared minus b squared, you can always factor it into the following. Now you got to pay attention closely. It factors into, and see, instead of doing like 2 steps here, writing all this and then writing the answer, you could just write the answer right away. It will be a without the little squared, okay? And then plus b. This gets confusing for some students. So without the squared, so I should have been careful about that. So it's without the squared, so plus b. So there's a plus sign here and then a minus sign here. But it has to look exactly like this. And then a minus b. It always factors into this. So there, notice there's no squared there or there or there or there. It's just a and b now. And there's a plus sign here and a minus sign there. But in order for you to use this formula, you have to have a negative sign here in the middle. Why? Because it is the difference. Difference means minus of two perfect squares. And a perfect square is here and there. A perfect square, a squared is one, b squared is another. Okay, so then if you applied that to this, you would just go, oh, well, r right here, r would go right here. So it would be r, and then the square root of 9 was 3. So it would be plus 3, r minus 3. That's just another way to do it. That is factoring review.